Hi, my name is Kelver Merlotti, and in this CodeRage session, we are going to explore FireDAC about performance and multi-DBMS support. So, FireDAC is a solid, robust, and powerful data access framework. It follows the dataset classes standard, what makes it closer to other frameworks like the old BDE and facilitates the migration from them. It is cross-platform, being able to be compiled for Win32 and 64-bit, macOS, iOS, and Android. It is cross-database, supporting all the main DBMSs in the market. It has a unified API with high performance and easy deployment. In a picture, we have all the FireDAC layers, and we can see that they are logical and clearly separated. We have non-visible components and visible component layers, the local data storage that supports XML, JSON, and binary format, the data adapter, and both layers can be debugged and monitored by its own mechanism, and the native driver layers that implement all the client API calls, and they are compiled and linked into your executable. That's what makes easy the deployment. So you don't need to send nothing beyond your executable and the DBMS client software that you want to use. About performance, FireDAC has great mechanisms and features to reduce the network traffic and the DBMS workload. We will see as an example the command batch feature, the array DML, synchronous commands, and batch move. About the portability, that means the multi DBMS supports, we're going to talk about data type unification, one of the most problems when dealing with multiple database management systems. We're going to talk about SQL dialect abstraction, macros, unified exceptions, and in my opinion, one of the greatest features FireDAC has, that is local SQL. Now, let's do some hands-on and see this in practice. So here we are with the first example, that is command batches. I will first run it and show it working, and then show how it is created. Uh, so the focus here is to execute two SQL statements, first with the normal way, that is open two queries. Here we have 500,000 customers and 300,000 products being fetched in 2 seconds, in about 2 seconds. And in the batch way, we have the same two SQL statements, the same number of records, but they are executed in a single way, and it reduces so much the time spent. So let's see how this works. How can FireDAC get this improvement? Well, on the interface and the buttons, we only have a call to both procedures, SQL normal and SQL batches. And the SQL normal, what we have here is a connection closing, and we are clearing our memory tables, that are used to store in memory the data fetched by the queries. So we get the start time, open both queries, and get the time spent. After that, we copy the data of both queries to respective memory tables. This is the normal way to go. You open single query to do single SQL statements. Now, the batch way is almost the same, but with two differences. First, we are disabling the auto close option. This tells FireDAC, tells the query to don't close itself when all the records are fetched. Itself, when I say closes itself, it is not the query by its own, but its internal cursor. So we are telling it to don't close itself. Why? Because we will have both SQL statements in a single query, in a single component. So if it reaches the end of this table customers and auto close options is enabled, it would close itself. So we need to say to it, hey, please don't close, wait my command to close you, and now we are able to get the second one. So that's what we do here. We clear the memory table and get the time when it starts, open a single query with both SQL statements. It will fetch the records of both statements, then we get the time expand, copy the data that is the first SQL statement inside the FD query to the first memory table, and call the next record set method, that is the other tick to do. So we first execute the first statement, get its data, call the next record set. It will make the query to stop in the second statement, and then we can get its data to the memory table. So running more than one query, more than one statement in a single query can improve performance, and this is a great tip, a great feature that FireDAC has. Now let's see the other one, that it's array DML. Here we have the form. Again, let's run it first to see it working and then see how it is done. Well, we will insert 2000 records in a table first in the normal way. Let me start my interbase first. It is probably up about many times, and no, it's not up. That's why it didn't work it. Now let's try to do the insert again and see how long it takes. So almost 10 seconds to insert 2000 records. Now with the array DML, it expands less than 100 milliseconds. It's a huge difference. So how is it possible? How does FireDAC help us to get this kind of improvement? Again, let's see first the normal way. Of course, we have the time initial, the initial time, and then we do the insert as we always do, passing the parameters to the query and executing it each time for the amount of records we want to insert. So it pass the parameters and execute, go to the next, pass parameters, execute, go to the next, and then get the time expand. But in the other way, in the array DML, what we do here is a little different. First, we tell the params property of the query how is its size. It is, we are telling them to have 2000 parameters inside its query. Then in the for statement, we don't execute the query, we just pass parameters to each position of the params array. After all the parameters are set, then we execute the query in that same number of rows we want to insert. It means that FireDAC will talk with the database a single time with all the parameters we want to insert, and this way achieving the great difference, the great improvement of performance. So the next one, synchronous commands. It is really common when we have slow operations in our software, and not always we can improve and optimize the SQL statements, and sometimes it is hard to make the user wait for what is happening. If he doesn't see the application working, the screen updating, it will think that your software has crashed, and you know the problems you have with this. So FireDAC has two options to help us get a better way to deal with slow statements. One of the options is execute the query with in a sync mode. It means that when we open the query, our application isn't, our interface, user interface is not locked. You can see that the timer is still running, it isn't locked, and we have a progress bar here just to see it in practice. So everywhere you have a big SQL statement that is slow, you can use this kind of feature. And the other option is a little different of the sync, because it allows the user to cancel the operation it starts, and you can stop that SQL processing. How this works, let's see in practice. Well, here in the open, we are just opening the query, but before it, we are setting the execution mode. The AM blocking is the default, of course, that blocks the UI and it doesn't respond to the user until the query is finished. We have the AM async that runs the query in a separate thread, allowing the user interface to be free and unlocked, and the cancel dialog that shows that small dialog allowing the user to cancel the operation. This is all we need to have this feature, to have this working. Only set the execution mode, and of course if it is async, what we need to do beyond this is to take care of the user interface. If your query is processing, the user can't deal with the UI. It can't scroll down the DB grid, for example. So what we should do is in the query events, in the before open, is to appoint the data set to a new data set, the data source property, data set property of the data source to a new data set, so the DB grid won't affect the query that is running. And after open, we point the dataset to make it work as expected. And in the after get records, in this case, we are just setting the progress bar style to normal in order to make this part of the screen stop to animate. So these two options: first, set the execution mode, and then take care of the events of the query you are running. Just it, and you are able to run asynchronous commands with FireDAC. So let's see our next sample. Batch move then is more related to your performance than the software performance. It's more related to your productivity, because every time you need to move a big amount of data from a source to a target, you can use this feature. If you were a BDE user at the past, you probably used the batch move that exists there, and it is almost the same with FireDAC, with a better performance and more features, of course. As usual, let's run it and see it working first. Here we have an open button that opened a table in the SQL Server, a customer table in the SQL Server, and a customer table in the Interbase database. And the second table is empty. We also have here in the directory a file that I will delete first to see this working. So the first sample, the first button shows a data export where you are getting the data from the SQL Server customers table and exporting it to a text file, and it executes really fast. As you can see, all the data here. The other option is the import of the feature where we are getting the data from this file. Let me just change something here and save it to be sure it is working. Now it is important, and here we have the new data imported right from the text file. Let's clear this table, and here a move, an export and import operation direct from SQL Server into Interbase Server tables. Now let's see the code to do this. Here on the form, the calls of the form are just called to the data model methods like get data, table to text, text to table, and table to table. Beyond the interbase empty table that is used to clear it before the move operation. And in the data module, let's see what we have here. The get data is just a close and open both components. We have here the source query and target query, and the component that makes all the magic, the FireDAC batch move. Let's see the code first, as we were doing. The get data we already see, and table to text. Take a look how easy it is to do the job. You just need to set who is the reader of the batch move and who is the writer of the batch move. The reader can be a dataset reader or a text reader, and the same happens with the writer. It can be a text writer and it can be a dataset writer. Once you have defined who is the reader and the writer, you just need to call the execute method. And when you are dealing with text files, you can call the guess format that will read a few lines of the text file and try to define what are the formats that it's used. For example, the character that is separating fields, that the datetime format, number formats, and so on. Of course, you can define these options manually, but you can, with this line of code, ask for FireDAC to identify it. So here in the batch move, as we were seeing, the main properties are the reader and the writer, but we also have other properties. For example, how lines it will analyze to try to identify the format. You can define some log file to FireDAC report what he is doing, the maximum errors, number of errors you expect, and so on. And in the text reader and writer, we have the data def properties that defines which character is the delimiter at the end of line. You can use the Windows or POSIX format settings of the values, or the values of your text files, and so on. So, powerful way to move data from a source to a target, being this source or target a text file or a DBMS table. And what is interesting here is that the dataset you use, if you are dealing with a dataset reader or dataset writer, doesn't need to be a FireDAC dataset. It can be any dataset you want. So you can do a data move from FireDAC to DB Express or to any else dataset you want, since it supports the methods that batch move executes. So a really nice feature related to your performance, to your productivity, and these 4 samples are the ones related to performance. Now we are going to talk about the multi-DBMS support, starting with the data type unification sample. So one of the big difficulties we have when dealing with multi-DBMS is the field definition. Here we have a FireDAC connection pointing to an interbase table, and we also have the same structure in a SQL Server table. If we come here in the dataset and add all the fields, we can see that it works with interbase, but when we try to open the query with SQL Server, an error occurs. He's saying that in SQL Server the field isn't single, it isn't float, it is single, so it won't work. If we don't work with the fields in the persistent property, of course it will work. FireDAC can understand and regenerate both fields for any database we're working, but this is not what we expect. We would like to work with all the fields added in the dataset to have more productive and so on. So how we can do this? FireDAC has an interesting feature that is called mapping rules. Here we can tell FireDAC what data type conversion he needs to do in order to work with all the data sets. For example, I want to tell it that all single field it detects in the source database, he will add this field in the data set as a double field. DT double. Let me find it here. Double. Once this is done, we can add the fields, and this let me see here. Let me change this again. Let me see if the setting is persisted. Okay, let me delete the fields and add it one more time in order to be sure. And now when we run, we have Interbase working and also SQL Server working with the same fields added in the data set. So you don't need to worry in which DBMS you are connected, and FireDAC will deal with the data type differences for you. One interesting thing and one important thing to mention in here is that you always need to convert to a target that is equal or greater than the source in terms of precision if you don't want to lose any data. So that's one of the hardest things we should deal with multiple DBMS support, and FireDAC help us to pass by it. Another sample regarding multi-DBMS support is SQL dialect abstraction. Again, here is a strong SQL editor that I created, and we can execute this statement in Interbase and SQL Server. But what if I want to use some specific features from Interbase? For example, I want to get the first 3 rows from Interbase. Excellent, this works, but in SQL Server, no. SQL Server doesn't know this command. In SQL Server, it is top. So one of the way you can do this is using this kind of feature. You can write your conditions inside your SQL statement. For example, if it is Microsoft SQL Server, then you use top 5 and you'll finalize your if. And the same here to Interbase. If it is IB driver, and you finalize your if. With this way, you can execute the same statement in Interbase and SQL Server. And there are other options. For example, if I select ID and the name field, and I want to get the name in uppercase, we don't know if Interbase and SQL Server has the same functions to upper the letters, but FireDAC has its own. So you need to write uppercase name as name, and it will work. It's UCase, I guess. Yes, and FireDAC converts it in runtime to the respective DBMS function for any DBMS it supports. And more about these functions, this FireDAC command preprocessing, you can take a look in the doc wiki. There are great number of functions you can use here. They are all the ones you can use: character macro functions, numeric key, date and time, and so on. For example, in character macro functions we have the L keys and U keys and so on. So you don't know which is the function in one of the DBMS you use, but FireDAC knows, and you can use this. So another great feature you can use in order to support multiple database management systems. The other sample about macros is really interesting because now you are able to put parameters in any part of your SQL statement. Here, just to show it working, you have 4 parameters that are table, field, decimal, and value, and we are creating a dynamic SQL to execute this filter. But we can do it in another way. For example, I can change for the field name using like everything that finishes with 0, and it work. You may be thinking that it's done with a dynamic string creation, but no. As you can see here, there are no code to create the string. What I have here is macro. Inside the query, we have select all from table. Yes, it's a parameter to define which table you access, and where, field, signal, and value. FireDAC doesn't know what will be this SQL statement, but when you pass the values to them, it pre-processes the SQL before send it to the databases. So when we click on the execute button, what it do in this case is go through all the rows of the value list editor, that is this component here, and getting its values to all the macros it has. If when you define a SQL with macros, they are here in this property, as you can see. Let me put it down. We can define the data type and the value of this macros. So FireDAC will process them in runtime and replace for what you put inside it. And this way you can, in another way, support differences in your multi DBMS systems. Okay, so unified exceptions. Let's take a look at this. Here we have a sample about dealing with the exceptions. As you might know, each DBMS raises exceptions with its own codes and its own messages. So it's kind of hard to be prepared for all the kind of exceptions when you are dealing with multiple DBMSs. So what FireDAC has is a special kind of exception that is FDDB engine exceptions. When you're not using it, you can see when you're trying to execute a duplicated insert, we are trying to insert another record with the same value of an already existence primary key. IB shows these messages and SQL Server shows these messages. You can see that there are no similar thing we can use to compare it by exceptions, although it is the most way developers do it. If pause key in e.message, then key violation is raised in your application. Well, it works, but it's not guaranteed that it will work exactly in all the DBMSs. But if we use the FireDAC engine exception, we can be sure of what exception it raises. You'll see in code why I'm saying this, why we can be sure. And another option is use the GUI error dialog or FireDAC that shows us a friendly user interface with a lot of helpful information about the exception it raises, with the error code, the error kind, the message itself, which component raises this exception with which command text and which values of the parameters, and some other information, including the object that raises it. So in the code, let's see what's happening here, how we can use the FireDAC exception classes. First, in the buttons, we just call the set data method, saying if it is Interbase or SQL Server. And in the checkbox, we are enabling the second one if the first is enabled. So the set data is the method that does the magic. At first, we test each DBMS we are going to connect, and then set the parameters to its server, if it is Interbase or SQL Server. Then we do some tests. If we check the option to use FireDAC engine exception, on the exception method, we can test if the exception class is FireDAC engine exception. If it is, we have a property on the exception that is called kind, and here we can test if what kind of exception was raised, if it is UKI violated, FKI violated, if it is object not exist when the record was not found. So many errors, many exceptions that FireDAC knows for you independently of the DBMS you are connected. That's why I said you can be sure about the error you are catching, and not only confident to the message of the exception. And if we are using the FireDAC GUI, you just need to execute the error dialog. That is this small component you can customize for which framework you are working on, if it's VCL or FireMonkey, and the caption of this dialog. You can't customize it so much, it's only these two properties, but you can, for example, create a setting in your software that if you want to debug something, you can enable this setting and use FireDAC information in this dialog to help you. If the FireDAC dialog is not enabled, we do a simple text to show a message respectively with the database we are connected. And if we don't use the FireDAC engine exception, it's the way we always do this, that is try to test the generic exception and give the message of this exception in the memos that are on the screen. So here is the magic, is the FireDAC engine exception class that we can test what kind of exception is raised and work with it with more security with more, and you can be more sure about what is happening regardless the DBMS you are connected. And at last but not least, the local SQL feature that FireDAC has. I will, as usual, first see it working, and I would like to ask for your attention here because we have the sales data. Let me see why the bindings are not working. Bind source DB1 is this and this one. I think my Delphi has detected the other data module, so let's reopen it. Open the data model. Now we have customers and sales. Let's see if it's correct. It's set. Yes, customers. I guess this is sales, not customers. Yes, here and here the data query one. Let's see. Again, please pay attention that because we have the sales data in SQL Server, we have the customers data in Interbase, and we need to show them together. Who is the customers of each sales, and FireDAC do this in memory for you. Yes, you can have data in different sources, but read them together, live online and faster. That's why. That's why I guess. That's because I think local SQL is one of the greatest features FireDAC has. How does it works? Well, FireDAC local SQL component needs a connection and needs a list of data sets. This connection, that is this component, is where you can say to FireDAC that it uses SQLite, and you don't need to specify a physical file for this database because it's created and it's up on memory. In the data set is where you tell FireDAC local SQL what data set you are using, from where the FireDAC local SQL will get its data. And here we are telling them that the first data set we are calling table customers, and it's linked with the SQL customers, that is this query. And the second data set that we called table sales is linked with the other query, SQL sales. And in this component, FireDAC local, we also said that we want to use the schema name that is called local. It's not an obligation. You can optionally use the schema name, and once you have this done, this setting done, you define what are the data sets you are using and which FireDAC connection component will be used to manage the SQLite database it uses to do the job behind the scenes. You can use another query that is connected in the same connection of that local SQL connection, and in this you can do a SQL statement in the data sets you defined. So you are selecting all the records, all the fields from the local table sales, inner join the local table customers. Again, FireDAC will get the data from this data set, and from this data set put all these data inside a SQLite database in memory, and then you can use another FireDAC query to execute a statement, a select statement inside this online, in this in-memory database. Really fast, really powerful, and it works as all the FireDAC components in any platform. You can even use local SQL inside mobile applications that has natively the SQLite database inside them. And another interesting thing that we can mention is that the dataset list is not FireDAC dataset. Again, it is any dataset you can use. So if you use interbase datasets, if you use DBGO or ADO datasets, any kind of component, you can use it as a source. You can even use a FireDAC data source, FireDAC table or SQL query, or a FireDAC query that is connected into a connection, FireDAC connection, that is connected into an ODBC connection, for example, in an Excel spreadsheet. Yes, you can do a select statement, an inner join over a spreadsheet, over a text file, and your database, any database that FireDAC support. Really interesting. I love this feature. I use this a lot in my projects, and with this one we are finishing the samples, and now we go back to the live Q&A. So thank you for your attention. Here they are my contact information. Please feel free to stay in touch.